Okay, so last page for inverse trig functions here. First example is evaluate in radians without using a calculator. So these are all your unit circle angles. So just as I mentioned on the previous page, remember when we talk about sine inverse of an angle of x or whatever, we can only have values, angle values, between negative pi over 2 and positive pi over 2. Those are the only angles we can get out. So if we have sine inverse of 1/2, if we think about our 1/2, that occurs at 30 degrees or pi over 6. It also occurs in the second quadrant at 5 pi over 6, but because we're restricted, we can't go past pi over 2, we don't include it. So pi over 6 is our only answer. So same argument for cosine inverse, except that cosine inverse, we only get to look at angles between 0 and pi, including 0, including pi. So negative root 3 over 2, we can only deal in the first and the second quadrants from 0 to pi. So in the first quadrant, everything's positive. So this is out. So in the second quadrant, the angle that would give us root 3 over 2 would be 30 degree angle or pi over 6 angle. So this would be 5 pi over 6 only. We would not get 7 pi over 6 because of the restricted domain. And then tangent inverse of root 3, same restriction as the sine, except that, and not that it really is relevant in this problem specifically, but we only get negative pi over 2 to positive pi over 2, not including them because of those asymptotes. So root 3 occurs at the pi over 3's. So this would just be positive pi over 3. We wouldn't get that third quadrant angle, which would be 4 pi over 3 because of that restriction. So that's what these are like. Unit circle, but we're restricting our values on the unit circle. Now, the second set of problems is just calculator problems. So we're going to use a calculator to evaluate each expression to the nearest tenth. I'm going to do it in degrees. So as a reminder, make sure your calculator is in degree mode. We figured that out by hitting mode and make sure it says degree. All right, so arc sine is the same thing as sine inverse. So we do second sine inverse, 0.4328. Oops, 4328. All right, so the nearest tenth would be 25.6 degrees. And then the idea behind what this problem does is it says, okay, look at the positive. Look what happens when I input a positive versus the same number as a negative. So we're going to do the same exact problem, except that we're going to do negative 0.4328. And you see that we get the negative angle, and that's because of those restrictions that we have for sine. So we get negative 25.6. Oops. Negative 25.6 degrees. Same number, one's positive, one's negative because of the restrictions. So cosine, same thing. We do cosine inverse, and we're going to do the negative one here first. So it's going to be negative 0.7219. Now this should be a second quadrant angle, which it is, 136.2. And that's because of those restrictions. And if we did the positive version, just positive 0.7219, we would get 43.8. 43.8 rounded to the nearest tenth, first quadrant angle. So that's why we get some of these values and some of them versus others in our calculator, because our calculator does these restricted domains. All right, and then I'm just going to give you the answers for the last one. It should be negative 75.3 and then positive 75.3.